Hi guys, welcome back to Algebra 2 Easy. Today we're going to graph sine functions with transformations. Let's start with the first transformation. It's a phase shift. Phase shift is the same as a horizontal shift, and think about it. Horizontal shifts will shift our graph left or right. So if we have plus h shifts, that's going to shift us h units to the left. If we have minus h shifts, it's going to shift us h units to the right. And I know that's opposite than how you think, but please just make sure you memorize this. Now we have y is equal to sine of theta minus pi. That's going to shift you pi units, remember, to the right. Next we have y is equal to tangent of theta plus pi over 4. That's going to shift you pi over 4 units to the left. Vertical shifts are probably the easiest shifts that you have. Remember, it's going to move your graph up or down on that y-axis. So if you have plus k shifts, you're going to go up k units. If you have negative k shifts, you're going to go down k units. We have y is equal to tangent of theta plus 2. Well, that's going to shift 2 units up. Same thing for y is equal to cosine of theta minus 4. That's going to shift 4 units down. Do not forget our vertical transformations from last week. Remember, A either stretched or compressed our function. Move on and apply these transformations. First, let's talk about the amplitude. It is the absolute value of A. And remember, A is in front of your trig name. If I don't see an A, it's understood to be 1. So the absolute value of 1 is just 1. Now, remember your period was always 2 pi divided by B. B was in front of theta. We do have a B this time. It is 2. So we're going to have 2 pi divided by 2. 2 pi divided by 2 is just pi. Now, we do know also pi can be called 180 degrees. Now, phase shift is going to be inside the parentheses. So we have theta plus pi over 2. Well, that's going to shift our graph pi over 2 units to the left. So I'm just going to say left pi over 2. Vertical shifts is going to be your k, and normally it's at the end, but notice I don't see anything. So that means that we do not have a vertical shift, and that's perfectly fine. The midline, your midline is going to be where y is equal to k. We didn't have a k. So that means that y is just equal to 0. And think about your midline. It's going to be that line that cuts your graph in half. I'm going to highlight our midline of y is equal to 0. That's just going to be the x-axis. Let's graph our function. To graph, you know we make a table. Last week we started with 0, but that's not the case this time. You always start with a phase shift. So if we have a phase shift when we do this week, we're going to start with that. If it says left pi over 2, that means you're going to the left of 0, 90 degrees. So that's going to be negative 90. I always find it helpful to use degrees in your table, especially when you're dealing with a bunch of transformations. I think it just makes it a lot easier. To get the other 4 values in your table, you have to take your period and divide by 4. Our period is 180. So if we say 180 degrees divided by 4, we're going to get 45. So we're going to be counting by 45 degrees. So we have negative 90. Plus 45, so that's going to be negative 45. Plus 45, that's going to be 0. Then 45, and then 90. From last week, we noticed there was a pattern for sine. All of the y values were the exact same, and it didn't matter what function they gave you. Well, that's the same here. The pattern is 0, 1, 0, negative 1, 0. We're going to use that same pattern every single time we make our table. It may be a little bit different depending on if you have transformations. So let's go back through our function. We had this 2 here that was in front of theta. Well, that involved our period, and we've already taken care of that by making sure that we divide it by 4 here. We also have theta plus pi over 2. We've already taken care of that by making sure that we started with negative 90 degrees. So we are ready to plot our points. We have negative 90, 0. So to the left at pi over 2, and then 0. Negative 45, we know it's going to be in between 0 and negative 90, so it's going to be line right here. We have negative 45, 1. We have 0, 0. We have 45, negative 1. And then we have 90, 0. Remember, 90 is pi over 2. Go ahead and draw your graph. And then basically, we're just going to continue that same pattern until we have this whole graph filled. Got your three numbers. We have negative 1, 0, and 1. So we're at 0. We go up to 1, back to 0, down to negative 1. 0, 1, 0, negative 1. Okay, we're going to fill in that graph. Let's do the other side. We're at 0, so we're going to go down the negative 1, back to 0, up at 1. Again, 0, negative 1, back to 0, up at 1. Draw your graph. And now our function is completely graphed. This time we have 5 over 2 times sine of theta plus pi plus 2. Our amplitude is not 1. Notice we have 5 over 2. So we're going to take the absolute value of 5 over 2 and get 5 over 2. Our period is going to be 2 pi divided by b. This time, notice, if I look in front of theta, I don't see a number, so it's understood to be 1. So if I say 2 pi divided by 1, it's just 2 pi. We do have a phase shift. You need to look inside the parentheses here. We have theta plus pi. Well, that's going to be left pi units. Do you have a vertical shift? Remember, normally it's at the end. We see plus 2. That means we're going to go up 2 units. Also, we have a midline because y is equal to k, and our k was 2. So it's going to be y is equal to 2. And remember, that midline is going to basically split our function in half. So let's go ahead and graph this midline. Y-axis, here's 2, and you're going to draw a horizontal line. Make a table. Now, starting with 0, we're starting with our phase shift. And notice that our phase shift here is pi, the negative 180. To know what you're counting by, you're going to take your period and divide by 4. That's going to give you those other 4 x values that you need. Our period is 2 pi, which is the same as 360 degrees. Take 360, divide it by 4. We're going to be counting by 90 degrees. So negative 180 plus 90 is going to be negative 90. Then we add 90 again. We're going to be at 0. Add 90 again, we're going to be at 90. Add 90 again, we're going to be at 180. Same pattern as last time. It is 0, 1, 0, negative 1, and 0. Let's go back to the function to double check that we have all of our transformations taken care of. I'm seeing a 5 over 2 in front of sine. It's been multiplied. So you're going to make sure that you multiply all of your y values by 5 over 2. That's going to be a vertical stretch to your function. Next, I see that we have theta plus pi. We've already taken care of that by making sure that we started left 180 degrees. We have plus 2. That means that our graph needs to be shifted up 2 units, 2 all the way through. I like to simplify my table before I start graphing, so let's do that. Make a new table. We're going to be at negative 180. And then 0 times 5 over 2 plus 2. I'm going to get 2. Negative 90. 1 times 5 over 2 plus 2. Well, that's 2.5 plus 2. That's 4.5. 0. We have 0 again times 5 over 2 plus 2. That's going to be 2. We have 90. We have negative 1 times 5 over 2 plus 2, and negative 0.5. Last, 180. We have 0 times 5 over 2 plus 2. That's just going to be 2. Let's graph. We have negative 182, so that's negative pi 2. We have negative 94.5, so negative pi over 2 up at 4.5. 0, 2. 90, negative 0.5, so pi over 2, negative 0.5. 180, which is pi, up at 2. Draw your graph. And then we need to finish it. We need to go all the way to the right, all the way to the left. Other side, we have negative 270. Well, that's going to be negative 0.5. and the negative 360 is going to be at 2. There's my function.